Hello students, we are going to learn in this chapter the definitions related to cell, interresistance of cell, EMF of cell and terminal voltage of cell, and as well the relation between them. Let's start. So first of all, we are going to learn about the first definition, that is called electromotive force. Electromotive force in short is called EMF of cell. It is denoted by small e or capital E, or by, this is also called E in English. These all are English letters. It is a scalar quantity and its SI unit is volt. And what is EMF? EMF, maximum potential difference across the electrodes of a cell in open circuit. Okay, so what this definition refers to? The definition tells you that when maximum charge appears or accumulates on the electrodes of a cell, positive electrode and negative electrode, then regarding to that charge, the potential developed on those electrodes, the difference of those potentials is called electromotive force, and it is in open circuit. That means cell is not in used. Okay, we are not taking any current from the cell, we are just making the cell. So the charging process is going on. When charging process has been stopped, because there are two forces, chemical force and electric force, when they are equal and opposite in each other for each and every ion which was moving before that, then this is called equilibrium. In equilibrium, the charge accumulates on the electrodes. It's called the maximum charge, and regarding that maximum charge, the potential develops. On positive electrode, positive potential, negative electrode, negative potential, and the difference of these potentials is called electromotive force. Keep in your mind, we are not using the cell. Cell is being made by the internal chemical reactions, and charge is being accumulated on the electrodes of the cell. Now next definition, what we have the next definition? The next definition we have internal resistance of cell. Internal resistance of a cell. And what is internal resistance of a cell? It is a finite resistance offered by the cell inside it, and must keep in your mind, between the electrodes. Between the electrodes. So this is a finite resistance offered by the finite. What do you mean by finite? Finite means that you can calculate the resistance. Okay, that's why we are calling it finite resistance, and the resistance is between the electrodes. Okay, and what is resistance here? Resistance or interresistance is basically a result, not a cause. Okay, and when resistance comes into play, then there is a loss in kinetic energy of the ions, and what will happen again? Then ions will get slower. Ions will get slower. And then charging speed reduces. Charging speed reduces. So resistance is nothing but a result, and keep in mind it's not a cause. The definite result is related to a cause. What are the cause? We'll learn further. And when resistance comes into play, there is a loss in kinetic energy of the ions. Ions will get slower and charging speed reduces. Charging speed, the accumulation of charges on the electrodes, accumulation of the charges on the electrodes will get slower, will get slower. तो चलिए जानते हैं हम इंटर रेजिस्टेंस ऑफ सेल. फर्स्ट ऑफ ऑल व्हाट इज find the resistance offered by the cell inside it between the electrodes. It's called the inter resistance. What is resistance? Result, not a cause. Loss in kinetic energy of the ions. Ions will get slower, charging speed reduces. Inter resistance denoted by small r. SI unit is ohm and is a scalar quantity. EMF of cell, terminal voltage, inter resistance, all are scalar quantities. So now let's talk about what are the cause of interresistance. The number one cause of the interresistance is inversely proportional to the area. And what is this area? This is the submerged area of electrodes in electrolyte solution. As you can see in the two images that these two electrodes has more area dipped into the electrolyte solution, but for in this image the submerged area is less. So as per the observation, scientists have observed that interresistance is inversely proportional to the area. That is why if area has more emerged, less surface charge density. So let's continue. That if more area is emerged in the electrolyte solution, surface charge density will be lesser. What is surface charge density? How many charges? Here in this case we're talking about ions. So how many charges are accumulated in a small amount of area? So if area is greater, then the charges will have more space to extend or expand. Okay. So electric field will be reducing because if charges are closer, more electric field lines will be closer and denser, and more will be the electric field. As you can see here, I have written here, if sigma is lesser, electric field is lesser. Sigma depends on A. Q is fixed in this case. So less repulsion and charging will increase. That means more charge will reach to the positive electrode and more charge reach to the negative electrode in less time. And resistance will be decreasing. Keep in mind, what is resistance? Resistance is a result, not a cause, and it is basically loss in kinetic energy. But if we say that area of the electrodes dipped into the electrolyte solution is lesser, then surface charge density will be greater, electric field will be greater, more repulsion will be there, and charging will be slower. That means ions cannot reach on the electrodes in less time, and since they cannot reach in less time, definitely resistance will increase, current will decrease, and charging process will also decreases or reduces. Now the next cause due to which interresistance arises, it is the separation between the electrodes. If the separation between the electrodes is greater, then interresistance will be lesser, will be greater. Okay. So keep in your mind, if the separation between the electrodes is greater, the interresistance is also be greater. So as you can see here, the separation between the electrodes is greater, and more time will be taken by ions to reach the electrode, and hence charging will slower. So ions will have to cover long distance, and when they have to cover a long distance, they will come into contact with more ions, they will collide with them, and they will lose their kinetic energy. The kinetic energy will be lost due to the collision also, and there is definitely a reason that the greater the distance, the more kinetic energy is needed. So more time will be taken and less current will be flowing there, and charging speed will be slower. Now next, if the separation is lesser, charging will be greater. As you can see in this case, the D1 is greater and D2 is lesser. So ions will take less time to reach the electrodes, and definitely what will happen? Charging will be increased. Charging speed will be increased. Now the third point is there, interresistance inversely proportional to the temperature, and keep in your mind the kinetic energy is directly proportional to the root of the absolute zero temperature. Okay, here the temperature is actually the electrolyte solution. So if you increase the temperature of the electrolyte solution by this relation, the kinetic energy of the ions will also increase, and the interresistance will decrease. charging will increase, more kinetic energy, so it will take less time to reach on the electrodes, and definitely charging will be increased and interresistance will be decreased. Don't forget that the resistance will indirectly or directly affect the speed of the charging, and interresistance definitely a result, not a cause, and we are talking about the cause here. And if temperature decreases, that means the kinetic energy of the ions is taken from the environment or the other causes, and the kinetic energy will be decreased, they will get slower, charging will be slower, interresistance will be increased. Now let's talk about the rest of the causes on which interresistance depends on. So interresistance depends on the concentration of electrolyte solution. More concentrated the solution, more will be the interresistance. Charging gets slower and vice versa. What will happen here? As you can see. So let's talk about the rest of the causes of the interresistance. So R depends on the concentration of electrolyte solution. So what is the concentration of electrolyte solution? Less amount of water but greater amount of solution. But more ions will be there. If more ions are there, more interresistance will be seen there, and more collisions will be there. Hence, what will happen? The kinetic energy of the ions will be decreasing, and they will take more time to reach on the electrodes, and the charging will get slower, and definitely vice versa if less solution is there. So you have to clarify, you have to clear it that how much amount of solution has to be taken at the time, otherwise more amount of concentration will get slower the charging. Now next, the last one, interresistance depends on the nature of the electrolyte solution. What is the nature of the electrolyte solution? Ions can get easily be separated from their molecules when interresistance less, otherwise interresistance is more. So keep in your mind, if easily the ions can be separated from the interresistance, from the ions, then interresistance will be less. Why? Because if they take more energy to get separated, so energy will be lost. If they get less energy to be separated from their molecules, then they will get more energy. So the amount of energy is fixed. If they take more amount of energy to get separated, definitely they will give less energy to the system or the electrodes, and if they take a small amount of energy to get separated, then definitely the system will get more energy. Now the next last is terminal voltage. Terminal means final. Voltage is definitely a potential difference denoted by V. It's a symbol, it's a scalar quantity, its unit is volt. Its definition is the potential difference across the electrodes of a cell in closed circuit. What is a closed circuit? When cell is in use or current is taken from the cell. As you can see in the image, there is a cell and there are the electrodes, two electrodes, and the two electrodes and a bulb are joined by using a wire whose resistance is capital R. So if bulb gets glowing up, if it is glowing when it is connected to the cell, then you can say the cell is in use. Or if there is no bulb, only the wire is connected, if wire gets heated up, when you touch it, the wire gets heated up, then you can say that the current is flowing and cell is in use. So in this case, what will happen? What is terminal voltage? What is closed circuit? Keep in your mind that the ions cannot move inside. Why can't they move? Because when the cell is formed, there is an equilibrium occurs between the electrodes or inside the cell. Because there are two forces, chemical force and electric force, they are equal in opposite, equal in magnitude, opposite direction. So the net of the force will become zero. So ions cannot move inside the cell. But when you connect a wire from one electrode to another electrode, then what will happen? Electrons will start drifting from bulb to this wire and to this electrode. So the charge on the electrodes will decrease. So as the potential on the electrodes will decrease, but it will decrease up to an extent, up to a limit. The charge cannot become zero. Because as soon as the charge start decreasing on the electrodes, electric force will decrease At the same time, chemical force will increase, and chemical force will start charging the electrodes again, and the process goes until the amount of water does not become greater than the amount of electrolyte solution, and then the process stops. But at that time also you must keep in your mind the charge of the electrodes will not get zero. Okay, so when the circuit is closed, electrons get a new path, an outside path, to go from one electrode to another electrode. So they will go, because there is a potential difference. What is basically a potential difference? When you connect this wire with the negative electrode and this end to the positive electrode, so due to positive electrode there are less negative charge, due to negative electrode there is a more negative charge, and electrons will start moving from one end to another, one end to another. So due to this accumulation, definitely electric field is there, because charge is there, electric force is there, work is there, and that is the potential basically. So electrons will move from this end to this end, okay, and the negative charge will decreasing on negative electrode, positive charge will be decreasing on positive electrode, because electrons are reaching on the positive electron and compensating the loss of the electrons. Due to this, chemical force increases, electric force decreases, and definitely charging will start again. So keep in your mind, when the circuit is closed, the charge will not get zero completely, but will less to an extent, and the extent at which it is come, the potential difference is called the terminal voltage. Okay, so keep in your mind, the negative charge decreases up to an extent, positive charge decreases up to an extent, and for that extent the potential difference is called terminal voltage. Charging is going on, definitely the charge will go up and the charge will go from the outside circuit, then it become less and then increases and then decreases and then increases. The whole thing is going on. So terminal voltage we use in closed circuit, EMF we say in open circuit, and the resistance is in the both open circuit and closed circuit. Okay.